Right, complete the diagram above to show the missing energy values, okay? So energy in was 500, useful energy out was 180, so I did 500, take away 180, you can do this in a calculator, would have given you 320, okay? Same kind of thing here, 500, the wasted energy was 350, so that meant that the useful energy would be 150. Which type of energy is the input energy in an oil power station? That would be chemical. Which type of energy is useful output in each power station? So each of them, every one is useful, each one you use is useful, is electrical. Name the type of power station with the biggest... Name the type of power station with the biggest wasted energy. So looking at the diagrams on the previous page, that would be the coal power station. It's got the biggest energy on the bottom. Explain how energy can be wasted through heat and sound. Them energies then aren't useful to us. Again, thinking about the efficiency equation. So that's the total input. So the total that was input over the useful output. Okay, so if you were to look, the oil power station, the useful was 170. Everyone had the same total going in 500. Make sure you times by 100 to get it in percent. So whenever you see a percentage, make sure you times by 100. Main problems here with the waste products. So whenever you see carbon dioxide, that causes global warming. So whenever you see carbon dioxide, that causes global warming. Nuclear can cause radioactive cell mutations, and sulfur dioxide causes acid rain. So that's quite a good table to remember in terms of thinking about environmental problems. Okay, the diagram below shows the energy flow process from producing energy from gas. Okay, so you start with 2000 here. 600 is then lost as heat to the air, and 1400 is heated as steam. If you were to add that up, okay, that would give you 2000. Okay, so we're always going back to the initial value. Same kind of thing happens here. 1000 joules is used to rotate the wind turbine, 400 heats the air. Again, that adds up to 1400. So can you see how I managed to get the 1000 there, because it's got to add up to that 1400. Same things happening here. It's got to add up to this 1000 by here. We've got 700, so 1000 take away 700 would be 300. State the amount of useful energy output from the input of 2000. So the amount that is useful at the end is that 700 joules, which produces the electrical energy. Okay, use the equation. You will get given the equation. Okay, efficiency equals total input over the useful output. So the useful output was 700, total in was 2000 right at the beginning, times that by 100 to get your percentage, and that would be 35, okay? Calculate how much is wasted. Percentages are always in 100, so 100 take away 35, that would have given you 65. State 2 reasons why power companies should look at other methods producing electrical instead of using gas. Very low efficiency, it's only 35%. Gas is also a non-renewable source of energy, so will run out. Other things you could have talked about is that it will have CO2 emissions because it is a non-renewable source of energy. So when you burn it, it will release CO2, which causes global warming. Okay, so using the information on the graph opposite, answer the following questions. Write down the height of the sea at high tide, okay? So high tide is going to be 5 because that's your top measurement on the graph. Write down the time of the second high tide. So that's the first high tide. The second high tide then is going to be at 4 o'clock or 1600. Write down the time taken from one tide to the next. So 4 a.m. to 4 p.m. So that's 12 hours. Write down both times the water levels are the same. So that's going to be here. So it's either 6 in the afternoon or 6 in the morning, okay? Write down the time when no power has been generated at the same time, okay? Because there's a situation where they're both at the same level, so nothing's going to be generated. Using the equation that was given, calculate the efficiency. So maximum power, so you're just looking at the information in the table. So maximum power output, maximum power input, okay? Times by 100, put it in the equation. Really simple for 2 marks there. Okay, state 2 advantages of environmental generating electricity this way. It's renewable, so it won't run out. No CO2 emissions. You could have also put no use of fossil fuels or no nuclear waste. One disadvantage, it disturbs habitats. It's quite a large bit of equipment that you have to put in. Also can harm wildlife that would have already lived in the river by the barrage. Okay, lighting a home accounts for 18% of a typical energy bill. The total energy going in is 16. Light energy, which is useful, coming out because it goes forward, is 12. Heat energy, which is wasted, goes down. Okay. Total energy divided by useful energy, you will get this equation. Okay, be careful of the times by 100. Okay, so the total energy is the bit right at the beginning here. Okay, so that would be 16. Useful is the 12. Divide them, times by 100 gives you 75. Okay, so there is marks to be picked up here if you work your way through. Okay, so it says complete the table to work out which is a better lamp, basically. So the first bit they're asking to fill in is the number of lamps used in 5,000 hours. Okay, you need to go to the bit above. Okay, so here it says the lifespan is 5,000 hours, so you're only going to need 1 lamp. So then they're saying that each one's got 1,000 lifespan. Okay, so to get to 50,000 you need 50 of them bulbs. Okay, so that would be 1 mark there. Okay, cost of lamps used in 5,000 hours, well, each lamp's cost £2.50. You're only using 1, so you're going to do £2.50 times by 1. That would be the total cost. Okay, here each lamp costs 1, but you're using 50 of them, so times that together, so that is 50. So that's your second mark. Okay, them 2 marks, if you take a little bit of time just to read through it, are easy to collect. Okay, units used, they give you the information here. So units equals power times by 50,000. Okay, so the units used is 0.1. So you're going to do 0.1 times by 50,000. Put that in the calculator, you get 500. Same kind of situation now. You then go on to use this equation. Units used times by the cost of units. Okay, so the cost per unit is 20p. The units used was 500. So you would do 500 times by 0.20 because this is working in pounds. Okay, again, that would give you 100. The last little bit then, they said it was 600 for the cost of the lights plus the amount of energy. So you're using plus the cost. So you're using that one, add that one, would give you 650. Okay, homeowner refuses to buy LED lamps because they're more expensive. He thinks you'll lose money compared to the traditional non-filament lamps. Okay, so if you're looking at the total cost for the 50,000 hours, it is much better to buy them LED lights. You get more, you could buy way more lamps for the amount of money that he spent on the traditional lamps. Complete the diagram by labelling the information. So furnace, the steam spins the turbine, which makes the generator, which goes to the transformer, which goes to the national grid. The generator is this bit by here, which turns kinetic energy from the turbine into electrical energy to the transformer. The furnace turns chemical energy into heat energy. Okay. Then again, another equation, the input energy is going to be a total energy supplied. So that's the one that's going to go on the bottom. Okay. Electrical energy is what you want to make. Heat would be wasted. So you do that number divided by that number times by 100 gives you 30%. Okay. Complete the table for the security light and the power oven. So if I start with this middle one, the power input was 1,000, the useful power was 3,000, so you have to do 1,000, take away 300, and that would give you 7,700. Okay, this one then, we know we've got wasted and we know we've got useful, add them together, and that then gives you the total energy input. Okay, it doesn't ask you to do anything for the television at this moment in time. Okay, they are nice 2 easy marks if you just look at it and think about it for a minute. Okay, it then goes on to ask you, using equation on page 2, they will give it to you. Okay, we've seen this equation loads, this efficiency equation. So we do the useful, which is 80. Okay, total, which would be the power input. Okay, So then times by 100, so that would then be 40. Okay, write the name of the unit, double, that's watts. Okay. Again, if they want you to do this, okay, they will give you the equation. So we've written out the equation here. Units equals power times by time. Power has to be in kilowatts. Okay, the time is measured in hours, which is fine. So you'd have 1 times by 4, which will give you 4 kilowatts per hour. Okay, again, to work out cost, we've done all these equations and they will give you these equations on the day. Okay, you won't have a page 2 to look back on. They will give you these equations on the day. So cost equals number of units, which we've worked out here. If you work out a different number, it doesn't matter because you'll get something called error carried forward. Cost per unit is 15p. Because they're asking for it in pence, you would just do 4 times by 15. Okay, be careful. If they ask for it in pounds, it's something slightly different. State which item uses the most energy. Most energy would be desktop PC because it's up here, the highest one. In which year do the CRT monitor and the TV have the same number of units? You're looking for where they overlap. So that would be 2005. In 2005, which item costs 5 times as much as an LCD? So you are looking, so 2005, that's 550. 50 times by 5 then would be 250. So which one of them is at 250? That's the desktop PC. Okay, remember you have a calculator, you're not expected to do this in your head. Explain which item has the greatest improvement in efficiency between 2002 and 2007. The CRT monitor, because there's the biggest decrease in units used. Again, this equation will not be on page 2, it'll get given to you. So efficiency equals the useful over the total. So it's given it to you here. So they're saying, work out for the CRT monitor, the useful is 18, the total is 90, times by 100, 20 on your calculator. How many joules of energy does the CRT monitor waste? So 90 goes in, only 18 are useful, take it away from each other, that's 72 joules that are wasted. Okay, so calculate the cost of using an LCD monitor at the same amount of time. So 90 is the energy that goes into the CRT monitor, 30 is the energy that goes into LCD. So you're essentially saying that a third of the energy goes in, so it should cost a third of the price, which would give you 150. Okay, how much would be saved? So it's £4.50 to run the CRT monitor, it's £1.50 to run the LCD monitor, so £3 saving.